Alright, find the points of inflection and discuss the concavity of the function below. Find all relative extrema by applying the second derivative test, and we have our function f of x equals x cubed minus 3x squared. The first thing I have to do to find my points of inflection is find where my second derivative is equal to 0. So I find my first derivative, f prime of x is 3x squared minus 6x. And then the second derivative is just taking the derivative again. F double prime of x equals 6x minus 6. And to find my point of inflection, I start by setting this equal to 0. So I can factor out a 6. And x equals 1. This is probably my point of inflection, but I do have to test it. So I'm going to make my little chart here with x equals 1 and have some test value. And I'm going to evaluate the second derivative at my test value. So something to the left of x, let's say 0. Something to the right of x, let's say 2. If I plug 0 into this, I'll get a negative number. Once again, I don't really care what the actual numbers are. I just want to know if it's positive or negative. If I plug 2 in here, I'll get 2 minus 1 is positive. And so sure enough, since my concavity changes from concave down to concave up, then that means that there is in fact a point of inflection at x equals 1. Now this looks great, but I've got to write up my answer a little bit more formally. It says to discuss the concavity. That means tell me the intervals where it's concave up and where it's concave down. And so I see that it is concave down from negative infinity until that point of inflection at 1. It's concave up from 1 to infinity. And then I have a point of inflection at x equals 1. This is a coordinate point now, and so I need to go look and see what happens when I plug 1 into the original function. I get 1 cubed minus 3 times 1 squared, so 1 minus 3 is negative 2. And now I've got a nice formal answer for the first part of the question. Second part of the question said find all relative extrema by applying the second derivative test. We'd found relative extrema by applying the first derivative test, and that's when you make a chart like this using the first derivative. We're going to do this without using any charts at all by doing the second derivative test. So to rewrite my function here, I had f of x equals x cubed minus 3x squared. Now for relative extrema, that's where the first derivative is equal to 0. So f prime of x, finding that again, was 3x squared minus 6x. I'm going to set that equal to 0 so I can find my critical points, find where the derivative is 0. Looks like I can factor out a 3x. That will leave me with x minus 2 equals 0. So x can be 0 or x can be 2. Those are my critical numbers. And now to apply the second derivative test, what you do is you plug each of those into the second derivative, and we're looking to see if it's positive or negative. Here we're testing the concavity at my critical points. So f double prime of x, we'll recall, was 6 times x minus 1, right? Yeah. And so I'm going to take each of these and plug it in for x. So f double prime of 0 was 6 times 0 minus 1, which is going to be negative. Don't really care about the number, but I just need to know that it's negative. This means that it's concave down, and if my critical point is here, that means I've got a max. Do it again for f double prime of 2. And I'll have 6 times 2 minus 1, which is positive 6. That means it's concave up, And if I'm looking at that point right there, that means I'm at a minimum. Once again, I can't leave this for my answer. I need to list out the coordinate points. So my minimum occurs at an x value of 2. And if I plug 2 into the original function, I'll get 8 minus 12, which is negative 4. And I have a max at an x value of 0. And if I plug 0 into the original function, I will get 0. And that's a good formal answer for the second part of the question. We're done answering the question, but now I want to show you that we can graph a lot by hand without having a graphing calculator. Remember, we're thinking in terms of not having a graphing calculator. What can I learn about this function without sitting there and making a really tedious table of x and y values? For just that little bit of work right there, let's look at what all I've learned about this graph. I've learned that I have a max at 0, 0. I've learned that I have a minimum at the point 2, negative 4. And I've learned that I have a point of inflection at 1, negative 2. I've learned that from negative infinity to 1, negative 2, the graph is concave down. And I've learned that from 1 to positive infinity, the graph is concave up. And if you were to graph that in your calculator, that's a pretty good representation of what you would see right there in your graphing calculator. So I've learned exactly what this function looks like for just a couple minutes of work without touching a calculator. Kind of cool stuff.